Hi everyone, I am Juan Cruz and welcome to my Latin R talk. Today I'm going to talk about plumberizer R package. This R package is a helper package for Plumber, which will allow you to build easily your first Plumber APIs. We will be also talking about Plumber and its importance for the R ecosystem. I am Juan Cruz. I am a software engineer and I frequently write at r2prod.com about writing production grade R code in my blog at that site. Okay, so let's talk about plumberizer. As I said, this is a package that automates Plumber API creation for our packages. So first of all, let's show it. To install a plumberizer, just follow the link below. And it's a GitHub package for now, so remote install GitHub, and that's it. All these instructions are at the repository, but anyway, feel free to ask. Okay, so the plumberizer R package just have one function, which is plumberize. It has as first input the name of any R package. The R package can be a cron package, can be a local package, or any R package that you have installed in your computer. So as an example, let's plumberize the emoji package, which is in run if you want to take a look. And as a second parameter, we have to give the output file where we will write the Plumber API code. So let's make any new file, just hit enter, and that's it. The plumberizer R package will build for each exported function from the input package a plumberized code. Let's see the created file. So as you can see here, this was automatically generated by the plumberizer package, and it has all of the endpoints, and this code is ready to get run. So what I really like about the plumberizer R package is that we have a way of easily testing R packages or trying them out in a Plumber way. So we can write plumber, and copy paste what I wrote before, run, and this is a really nice script, line that we can run. And voila, there we have our Plumber API running automatically to test all of the exported functions from the target package. So for instance, we can find an emoji and try out how this endpoint would work, right? Well, that's it. Short showcase of the plumberizer R package, as it's quite easy to use. So let's talk about Plumber, right? So Plumber, why? Well, usually when we code in R, we code our web apps through Shiny, this amazing framework that we have. Usually our app users just interface with the Shiny code. So we have just a Shiny interface, which is in charge of the user interface, input validation, data access from DBs, databases, or wherever we have to input data. It takes care of the calculations, of the business logic, of rendering the output. So Shiny is taking care of everything. This is just a fat, Shiny architecture that holds all of our code, all of our calculations, and everything. So in modern web apps architectures, people try to modularize the code into different units. So the model view controller architecture, or MVC, it's a quite widely used architecture for building our web apps. It's an architecture that we can follow. It's just steps, good practices to follow. In the MVC architecture, we mainly have a unit called the view, which is the point where the users of our app interact with the apps. Then the view is just in charge of interacting with a controller unit. And the controller unit is in charge of passing the messages or handling the requests to the model. The model builds the response, and then the controller sends back to the view whatever the user has to see. In this architecture, the view is just in charge of the user interface, and that's it. No calculations, just the user interface, what the user sees in a web browser. The controller takes care of the inputs validation and the communication. So when the user interacts with the user interface, the controller should take care of checking that these inputs are valid, that we have the parameters set and everything, and then just communicate this inputs with the desired model that should handle this action requested by the user, right? And finally, we have the model, and the model is the one that takes care of the data access, the calculations, and all of the business logic. Of course, we might have multiple models. For example, we can have a model for modeling the users, one model for modeling analysis or reports. So this is not a unique unit. As we can see, anyways, the model has many tasks here. So an improved architecture for MVC tends to split the model into subunits for services and for DAO, data access object. The DAO takes care just of pulling the needed data or interacting with the database, while the service will take care of asking for this data and doing the calculations and doing all of the business logic. For instance, we could have a user service with functions to create a user, to pull user information, update user information. We can have a service for big analysis, which will have functions for run analysis, gather analysis results, and so on. So what are the benefits of using these architectures instead of just a big, shiny code architecture? Well, first of all, of course, you have seen all of these benefits in many places. One of them is separation of concerns, modularity, reusability, maintainability, and scalability. I will mention each of them next. But yeah, we have like the most important part here is separation of concerns and modularity. So, well, we should think about how can we follow this architecture in R? Well, of course we can. So for the view, we can use Shiny, just the UI functions from Shiny. So we would have like numeric input, text input, action button, etc. But just the UI part of Shiny. No server calculations here. Then for the controller, we would have everything from the Shiny server functions, but these server functions should be really skinny functions. We should just take care of getting the inputs, validating that the inputs are correct, and then just running one function that will take care of all the calculations given those inputs. And finally, it should take care of the communication. That's it, just calling the respective function we need to call from the model in order to manage this user action, right? And finally, how we manage the model? Well, basically with our packages. So our packages, which will have many functions that will take care of all the calculations, the business logic, and functions for just small functions that will work with the database or wherever we have our data. So in this way, we can take benefit of all of our knowledge about our packages. We have test cases, we have linter, we have stylers, we have so many tools we can use for regular R packages. So, well, if we think in this way, we know that right now our Shiny app has like modularized parts of code. But anyways, if we want to run all of this in a server, it will be just one big server running the big Shiny app and doing all of the calculations just in the same server. So here is where our Plumber superhero comes. So by using Plumber, we can just split all of this architecture into just the UI, just the UI and the front end part, and we can split the back end part, which will be handled with Plumber. In this way, we could have one server or Google Cloud Platform Service, as an example, just for the Shiny part. As you can imagine, this will be just a really small server, as it will have no calculations, just handling user inputs, user interactions, and showing the outputs, and yeah, just handling user interfaces. And we will have another server for the Plumber side. In this case, we can have just one server for the Plumber, or we can even have one server for every single service that we want to define. For instance, in the previous example, we can have just a small server for handling user services, just creating or editing users, and then another big server for doing calculations and reports, right? Okay, so as an example, imagine we have this Shiny application. It's called time-consuming analysis. It's an example that might have happened to most of you, or some of you at least, in which the application has multiple input parameters, a lot. So the user takes some time on selecting the correct parameters, filling them out, and then we have a run time and CPUs and RAM consuming calculations. Of course, when we click this button, we get a message of performing analysis, which takes a lot of time and it consumes a lot of RAM and CPUs. And finally, our application retrieves the output. And again, the user in our application will have to take some time analyzing the results, the plots, the tables, and whatever. So in this example, imagine that to make it easier to understand, the usage of our application is split into 3 equal time frames. 1/3 of the usage is for the user to input the parameters. 1/3 of the time it's taken by the analysis being performed, and 1/3 of the time for the user to analyze the results. So in this case, if we are developing in our Fat Shiny controller, Fat Shiny architecture, then we can have just one server. We cannot split a Shiny application in multiple servers. So we need a big server for the first part, for the analysis part, and for the output part. And the size of this server will be limited by the highest server usage part of the application, which in this example would be the analysis calculations time. And of course, big server means big bag of money being spent, which we don't like. Probably in first stage applications, it could be okay. We can afford it. So now suppose how would this be in the model view controller? As we said, we can have, for example, one server for the UI part, one server for the calculations part, and one server for the, well, this would be the same server as for the first part. So in this scenario, we could have just one big server for the calculations, as it requires a big server to perform the calculations. But we will have just one small server for 2/3 parts of the user interactions with our apps. So in this case, we have just one bag big of money and 2 small bags of money. So most even, more even we can have, if we have a tiny and fast calculations analysis in our app, we don't need to just build one Plumber API and give one big server for every single calculation. We can have another small server being run with another Plumber interface. So instead of reusing big servers, we can modularize and have even many more smaller servers. This is commonly known as microservices, and this is a great approach that Plumber allow us to do in R. Okay, so what am I talking about in this talk? Should you start coding Shiny projects from scratch following the MVC architecture? Well, of course not. You should code your Shiny apps as you are most used to, how is easiest for you. But just take into account and remember that if you are using a fat Shiny architecture, you will be attached to just use one server, which means one big bag of money. But hopefully, once our application reaches the 100 or 1,000 users, you know that you will be able to modularize your Shiny app by using Plumber to make it highly efficient and production-grade code by using just R code. Well, this was all of my talk. I'm eager to hear your questions. I'm Juan Cruz, and I really appreciate if you take a look at r2prod.com and let me know your thoughts there. Thank you very much. Thank you, Latino.